All right, 9.2. We kind of already talked about it in 9.1. We're just going to classify those numbers again. Again, looking at the number system. And remember, you can always listen to the number system song. I know you guys like that. Maybe, maybe not. But you have your natural numbers here, 1, 2, 3, 4, 5. These are your whole numbers. 0, 1, 2, 3, 4, 5, and so on. Integers, remember, are your whole numbers and opposites. And rational numbers, remember, that includes all of your whole numbers, all of your naturals, all of your integers, and your decimals that terminate and repeat, and your fractions. This is your irrational numbers. And remember, your irrational numbers are numbers that go on forever. They don't repeat and they don't terminate. So pi and non-perfect squares, those go on forever and ever, okay? Remember, they're all within the real number system. They're all real numbers, okay? And then the outside is imaginary numbers, but that's all you need to know for classifying these. All right, so name all the sets of numbers to which the real number belongs to. Remember, start in the center of the circle and say, is it natural? Yes. As soon as you say yes to natural, it's a whole, it's an integer, it's rational. So it's all of them, okay? So as soon as you say yes to natural, you can say yes to all of them. And it is all of them, natural, whole, integer, and rational. Negative 72 over 6, make sure you simplify before you identify that, because if you just try to identify it like that, you might only call it rational because it's a fraction. But remember, when you simplify it, it could be negative 7. Think about the circles. Is it natural? No, it's not natural to be negative. Is it a whole number? No, whole numbers are not negatives. It's an integer. And if you say it's an integer, you want to keep going out and say it's also rational. Okay? So it's not whole, it's not natural, it's not whole, but it is an integer and it is rational. Okay? Square root of 225, make sure you simplify before you identify. It's natural, it's whole, it's an integer, and it's rational. Name all the sets that this belongs to. This is a repeating number. And remember, repeating numbers are rational. So it's just rational. Square root of 52 is not a perfect square. It goes on forever and ever and ever and ever. It doesn't repeat and it doesn't terminate, which makes it irrational. 31 obviously is all of them. Negative square root of 81 is equal to negative 9, and negative 9 is an integer and it's rational. This is a terminating decimals. All terminating decimals can be turned into fractions, and fractions are rational. This is actually equal to 5, so it's all of them. And this is a non-perfect square, so it is irrational. So that's identifying numbers. So when you do this, you definitely want to put them in the same format, whether it be decimals, whether it be fractions, whatever. But you need to put it into the same format so that you can compare them and see what they look like. The square root of 125 is approximately 11 2/10. And if you remember your benchmark fraction 7/8, this is 11 875 thousandths. So you can clearly see that your inequality sign would be less than. So put them in the same format before you go and compare them. Putting these in order, you're going to do the same thing. You know that this is 6. You know that this is pretty close to being 6. You know this is 6 25 hundredths. So the square root of 38 is probably about 6 2/10. So from least to greatest, you can see which one's the smallest. The square root of 38, the square root of 36 is the smallest. then the square root of 38, then 6 1/4, then 6 5/10 repeating. So put them in the same format, then put them in their order. Same thing. As you think of the square root of 61, what two perfect squares is it between? Who is it closest to? It's closer to 8 than it is to 7. So I would say like 7 8/10. And this one is 7 75/100. That's a hard one to do without a calculator because it's so close, you know, to being the same. But you can see that this is greater. And then you're gonna do the same with this. Put these in order from least to greatest. Put them both all into decimals first. Okay, we're solving a new kind of equation. The only way that you can undo a square is to square root it. So you're going to take the square root of both sides and then get W is equal to, so remember what your square root of 169 is equal to 13. But in this case, you don't know what the story is. So you want to say that it's a positive or a negative 13 in this case, because negative 13 times negative 13 is also 169. So it could be a positive or negative answer. That is how you solve this equation. Same thing on this one. So you have r squared is equal to 50. Make sure you're paying attention that it's telling you to round to the nearest tenth. To undo a square, take the square root of it. So you're going to take the square root of 50. Remember, you're going to look at what two perfect squares is it between, that whole thing. So you're going to say r is approximately positive or negative 7 1/10, because it's really close to the square root of 49. Okay? Positive or negative 9. And then this one, positive or negative 4 9/10, because it's really close to being the square root of 25. And that's it for 9.2. Good luck.